There's a kind of comfort in engineering, isn't there? A very specific kind.
Oh, absolutely. Things are.
Yeah.
Well, they're right or they're wrong.
Well, exactly. If you build a bridge, it stands up or it falls down. That's it. It's physics.
Right. And in a calculator, 2 plus 2 is always 4.
And if it comes out as 5, something is fundamentally broken. It's objective. It's clean.
A clean pass or fail.
But we aren't talking about math today. We're talking about language. And language is, well, it's messy.
So messy.
If I ask an AI to summarize a news article and it gives me 3 sentences, how do I grade that? Is it an A because it was short, a C because it missed some key nuance?
And did it actually understand the text? Or is it just, mashing together words it found somewhere?
That is the multi-billion-dollar question, isn't it? And honestly, it feels like the fundamental bottleneck in NLP right now. We build these massive models.
Trillion parameter giants.
Yeah. But if we can't measure if they're getting any smarter, we're basically flying blind.
We are.
So today, that's what we're doing. A deep dive into the playbook on this. We're unpacking Chapter 17, simply titled Evaluation, from Methods and Dimensions of NLP Evaluation.
By Rebecca Passano and Inderjeet Mani. And it's such a great source because it frames this whole problem perfectly.
It really does. And I want to be clear for everyone listening, this isn't just about debugging. This is almost about the philosophy of correctness.
Yeah.
How do we even decide what good language looks like?
It's a philosophical text disguised as a technical manual. It's fantastic.
Right.
Passano and Mani frame evaluation not just as a technical hurdle, but as a conceptual one.
Right.
So we're going to explore there are 4 dimensions of evaluation, the whole trap of the so-called gold standard, and why the metrics we lean on things with fancy names like BLEU and Rouge might actually be encouraging AI to lie to us.
That's the part that just blew my mind. That our grading system itself might be warping the intelligence we're trying to build.
Yeah.
But let's start with the framework. The authors lay out these, what they call the 4 dimensions of evaluation, to help researchers figure out what they're actually testing.
And the first one is this big distinction between intrinsic and extrinsic evaluation.
Which I gotta say sound a little academic, right?
Yeah.
A bit abstract.
They do. They really do. But they map to something super practical. The analogy with cars is perfect here.
Okay, lay it on me.
So intrinsic evaluation is like putting a car engine on a test block in a lab.
Right.
You're measuring the RPMs, the torque, the fuel injection. You're asking, does this specific component meet its own engineering specs?
So in NLP terms, if I've built a summarizer, an intrinsic test would look at the summary itself.
In isolation.
Is the grammar correct? Did it actually cut the word count by 50% like I asked? Did it, hallucinate facts?
Exactly. You're looking inward at the system's properties. But extrinsic evaluation, that's when you take that engine, you put it in the car, and you drive it to work. The question totally shifts. It's not, does the engine run anymore? It's, does this car get me to my destination faster?
So extrinsic is all about utility. It's about the human user.
Precisely. For our summarizer, an extrinsic test wouldn't care so much about the grammar. It would ask something like, did reading this summary help a human analyst answer a security question faster than reading the whole document?
That is a huge distinction. A system could have perfect grammar, a high intrinsic score, but be totally useless for the job.
A low extrinsic score.
Yeah.
Absolutely. It's like having a Ferrari engine in a car with square wheels.
Which happens more than you'd think in AI research, right?
It does. People get obsessed with the intrinsic metrics because they're easier to control, but they lose sight of the extrinsic goal, which is actually helping a human do something.
Right.
And this connects to a concept they bring up called ablation studies.
Which is a term from biology, I think. It sounds like removing tissue.
That's exactly where it comes from. But here, you're removing code. You take a complex AI system, and you maybe turn off the spell checker module.
Or the part of speech tagger.
Yeah. And you see how much the overall performance drops. It's like pulling spark plugs out of that engine one by one to see which ones are actually doing the real work.
Okay, that makes sense. It helps you figure out what's important inside the box. Speaking of boxes, that brings us to the second dimension, standalone versus component. This feels related to what they call glass box versus black box.
It's directly connected. The black box is what most of us do as users. You put an input in, you get an output.
You don't care how the sausage is made.
Right. You just judge the taste. That's a standalone evaluation of a full app like Google Translate. You type English, you get Spanish. Is it good?
Whereas the glass box is for the developers. You can see inside. You can test all the individual gears, the components.
And that's crucial because a full application is usually a pipeline of these components. You might have a parser, then a word sense module, then a text generator.
And if the whole thing fails, the glass box approach lets you see which gear is stripped.
Otherwise, you just know it's broken. You don't know why. You might throw out the whole thing when maybe 90% of it was perfect.
Okay, let's move to the third dimension. This is the one that causes the most friction, the most debate. Manual versus automatic.
Humans versus machines.
It's the eternal trade-off.
It is. So on one side, you've got manual assessment. The authors talk about the Eagle framework, which is basically a detailed checklist.
Like a consumer report for software.
Exactly. Real humans sit down and ask, is it usable? Is the interface good?
And, most importantly, does the output actually make sense? Humans are the ultimate judges of meaning. We get the nuance, the sarcasm.
All the stuff a machine misses.
The
But
problem is obvious. Humans are slow.
so slow. And expensive.
Yeah.
And just incredibly inconsistent.
That's the moody factor we always joke about.
The technical term is subjective, but yes.
Oh.
You and I could grade the same translation of a French poem and give it completely different scores.
Right. I might value literal accuracy. You might want poetic flow.
And that subjectivity is a nightmare for a developer. They need a yardstick that doesn't change length every time they use it.
So the industry pivots to automatic evaluation. It's fast, it's cheap, it's repeatable.
You can run it 1,000 times an hour.
But, and this is the huge catch, for a computer to grade another computer, you need an answer key. You need what the authors call the gold standard.
The gold standard.
Yep.
Which is usually just a human-created reference. So for translation, the gold standard is translation done by a professional human translator.
The computer just compares its output to that human version. But this is where we hit that philosophical wall again. Language isn't math. There isn't just one right answer.
Exactly. If the sentence is, the cat sat on the mat, and the AI says, the mat was sat on by the cat.
The meaning is identical.
But a rigid word-for-word comparison would just mark it as wrong. The words are different. The order is different.
So how do researchers get around that? Because a metric that brittle is useless.
Well, for machine translation, they try to solve it by using multiple references. Instead of one human translation, they'll get 4 or 5.
To try and capture the different valid ways of saying the same thing?
Right. And then they use a metric called BLEU.
BLEU, the bilingual evaluation understudy.
That's the one. It's the grandfather of these metrics. And BLEU works by looking at n-grams.
Okay, let's just clarify that for a second. An n-gram is just a sequence of n words. A unigram is 1 word, a bigger gram is 2 words.
Exactly. So BLEU looks at the machine's output and asks, how many of these 4-word clusters, these 4 grams, also show up in the human reference translations?
The more overlap, the higher the score.
And it adds a brevity penalty so the machine can't just output the word the and claim 100% accuracy.
It sounds logical, at least on the surface. If you're using the same phrases as a human, you're probably doing a good job. But the authors point out a massive, massive flaw.
Oh, yeah. You can game the system.
And the classic example of this is the Systrand case from 2005. The story is just perfect.
It's legendary in the field because it just exposes the absurdity of it all.
So walk us through it. Systrand was an old-school, rule-based system.
Yeah, no statistics. It used grammatical rules written by linguists. And when humans rated the Systrand translations, they gave it top marks for fluency.
It sounded like natural English. It flowed.
It did. But the BLEU score hated it.
The scoreboard said something completely different.
Completely. Systrand was beaten by 5 other statistical systems. And the question is why? Because those statistical systems were designed, whether consciously or not, to optimize for anagram overlap. They picked the words most likely to be in the reference, even if it meant sacrificing grammar or flow.
So you end up with these clunky robotic sentences that just happen to have the right keywords.
And they beat a fluent sentence that used a valid synonym.
That is a perfect example of Goodhart's law. When a measure becomes a target, it ceases to be a good measure.
Exactly right. The statistical systems were teaching to the test. Systrand was trying to speak English. The metric rewarded the test takers, not the speakers.
High score does not equal high quality. That is a sobering thought for anyone looking at those AI leaderboards on Twitter.
It really is.
So let's pivot to summarization. If translation is hard to grade, summarization feels, I don't know, almost impossible.
It's so subjective. In translation, you have to preserve all the meaning. In summarization, you have to decide what to throw away.
And the authors distinguish between 2 main types here, extracts and abstracts.
Right. And the extract is basically just a highlighter. It pulls full sentences from the original and pastes them together.
Which is safer, because the grammar is usually fine. It was written by a human.
But an abstract tries to generate new sentences to capture the gist, more like a human would.
But those extracts have this very specific failure mode they mention, the dangling anaphor.
It sounds like a medical condition.
It does. So an anaphor is a word like he, she, or it that refers back to something. So if the original text says, President Smith signed the treaty, he then left the room.
And your extraction system decides, you know what, that first sentence isn't that important, I'll just grab the second one.
So the summary just says, he then left the room.
And the reader is left asking, who is he? The janitor.
Yeah.
The assassin.
Exactly. The context is completely severed. So for the content side of things, for checking if the AI got the main points, they use a metric called rouge.
The cousin of BLEU.
Right.
But where BLEU is usually about precision, did the words I wrote show up in the reference? Rouge is about recall.
So it's a coverage test.
Yes. It asks, of all the important words in the reference summary, how many did my machine manage to capture? Again, just relying on word overlap is tricky, which is why I love this other method they describe, the pyramid method. It's manual, but it's so much smarter.
This is the one that accepts that different humans will summarize things differently.
Correct. You get, say, 5 humans to summarize the same article. Then you analyze those summaries to find summary content units, basically distinct ideas.
So if 4 out of the 5 humans mention the oil price spiked, that idea goes to the top of the pyramid.
It's a tier 1 fact. If only one person mentions it was raining that day, that's at the bottom. Then you grade the AI summary against that pyramid.
Did it capture the important stuff at the top?
Exactly. It's evaluating the weight of the information, not just counting keywords. It's consensus-based. It feels much more robust.
Okay, I want to zoom in on the components again. We talked about the gears. The text goes into information extraction and word sense disambiguation.
Information extraction, or IE, is huge for business. It's about turning unstructured text, like a million emails, into a structured database.
Names, dates, locations, events.
And for that, we have to define 2 key metrics that people often mix up: precision and recall.
The bread and butter of data science.
Okay, the best analogy is fishing with a net. You're trying to catch tuna. Precision asks, of all the fish currently in your net, what percentage are actually tuna? If you caught 10 fish and they're all tuna, that's 100% precision. You didn't catch any junk.
Okay, simple enough. And recall.
Recall asks, of all the tuna in the entire ocean, how many did you manage to catch? So if there were 1,000 tuna out there and you only caught your 10, your precision is perfect, but your recall is terrible.
Because you missed almost everything. That's a great distinction. So a spam filter needs high precision.
You don't want it catching a real email.
But a search for cancer treatments needs high recall.
You can't afford to miss a single one. It's a trade-off, which is why researchers use the F measure, which is just a mathematical way to balance the 2.
But the source points out a huge crisis when it comes to extracting events.
This is staggering. They cite data from the ACE 2005 evaluation, where they ask humans to identify complex events in text, like a conflict event.
Right.
The inter-annotator agreement was only about 40 to 50%.
Wait, hold on. Let that sink in. 2 humans read the same news story, and they basically flip a coin on whether a specific event happened or not.
For complex, nuanced events, yes. And this raises a massive red flag for the entire field. If the gold standard, the human baseline, is that fuzzy, how can we possibly grade a computer against it?
We're holding the AI to a standard we can't even agree on ourselves.
Like trying to calibrate a scale when gravity keeps changing.
And that ambiguity trickles all the way down to individual words. The section on word sense disambiguation. The example with the word name is perfect.
Right. Name seems simple, but look at the context. Sense 1 is to appoint, as in they named Chris Christie to the committee.
Okay.
Sense 2 is to Kristen. Clinton named his dog Buddy.
They're subtly different. One is assigning a role, the other is assigning a label.
And to evaluate a system on this, you need a dictionary like WordNet with all these senses listed. But the lines are so blurry.
Is it a metaphor? Is it both?
The authors basically say that creating a gold standard for word meaning is, and I'm quoting here, not quite a science.
Which brings us to the idea of value. The ACE evaluation introduced a weighted metric because not all errors are created equal.
This is where evaluation finally meets the real world. Standard metrics treat every error the same. Missing a comma is an error. Missing a suspect's name is an error.
But in a security application, missing the name is catastrophic. The comma is irrelevant.
So the value metric assigns a cost to different types of errors based on what the user actually cares about. It makes the score reflect business utility, not just linguistic perfection.
But before we can even trust that score, we have to talk about kappa. If human agreement is only 40%, we need a way to quantify that.
You do. You can't just trust the gold standard blindly. You have to measure the inter-annotator agreement. The kappa coefficient is a statistical tool that does this.
And it measures agreement beyond what you'd expect just by chance, right?
Exactly.
Yeah.
Because if there are only two choices, true or false, two people guessing would still agree 50% of the time. Kappa subtracts that luck factor.
It tells you if the agreement is real signal or just noise.
Right. But the source points out that while checking this is a best practice, it's expensive, so people often skip it. They're building their house on sand.
So, if we step back and look at all of this, intrinsic, extrinsic, glass box, BLU, rouge, where does this leave us? What's the takeaway?
I think the big synthesis is that evaluation is always this tension between quality and informativeness.
Quality being the form, the grammar, the flow.
And informativeness being the content. Is ACK accurate? Did it capture the right data? We've built all these complex metrics to approximate these things, but none of them are perfect.
The text does mention a move toward newer metrics like BERT score. That seems to be a shift from matching words to matching meaning.
It is. BERT score uses vectors mathematical representations of meaning. So feline and cat would be seen as similar, where BLU would see them as totally different. It's getting closer.
But here's the thought that I can't shake, and the source alludes to it. We rely so heavily on these recall-based metrics, checking items off a list. Did the AI say what the human said?
Right.
But language is generative. It's creative. The list of valid answers isn't fixed.
And that's the danger. If we judge AI solely by how well it mimics a static set of human answers from the past, we are implicitly punishing creativity.
We're grading a brilliant new way of explaining something as an error just because it's not in our database.
We're training it to be an echo chamber, not a thinker.
By forcing it to sound like us, we might be preventing it from sounding better than us.
Precisely.
That is a brain bender to end on. We want the computer to pass the test, but maybe the test itself is the problem.
The map is not the territory, and the metric is not the meaning.
Well, I'm going to go perform an extrinsic evaluation on my coffee machine. Does it wake me up? That's the only metric that matters right now.
High value, high utility.
Thanks for joining us on this deep dive into the messy, messy world of NLP evaluation.
Always a pleasure.
See you next time.